I want to show you a demo that reports the current location of the mouse.
Let's do it just in a single pass here. So I can read the X location of the mouse by using standard draw dot. You see there's a mouse X method, and I can read the Y location, and I can try to print that out. So let's just print that out. X equal and Y. Okay, so there we go. Okay, so let's run this. And it put the X and Y location at 0, 0. It did this the moment the program started up, and my cursor happened to be in the middle, but it's not going to really see that because it doesn't have time to even do anything with where the cursor is. Every time I run this, no matter where the mouse is, it's going to report 0. It's not a very useful thing to do. So what I'd like to do is put this inside a loop and continuously report the location of the mouse. So I need a while loop, and we haven't seen this so much before, but I'm going to say while true, which causes this loop to run forever. I'll just say loop forever. And as I loop, I'm going to be reading the mouse and reporting about the location. So if I run this program, now the output's going kind of crazy, but you can see it is reflecting the location of the mouse. Now there are a couple problems with this particular approach. This looping forever is going to tie up your computer, and other applications are going to appear sluggish, and we don't want to ever be in a position where we're in such a tight loop without doing something to stop the program. So there is a way to do this in Sedgwick's API. There is a pause method, and I can tell it how many milliseconds I want to pause. I'm going to pause for 1,000 milliseconds now, which is simply a second, and that's going to slow down the computer. That's going to slow down your program by quite a bit. And so every second we're reporting on the location of the mouse. I can be all the way down here to the left where it's close to 0, 0, all the way up here on the right where it's close to 1, 1, or in the middle where it should be close to 0.5. I can try to get it exactly at 0.5. That's kind of a tricky thing to do, but there I'm pretty close. If this were an animation kind of exercise, a second is too long to pause, so I could pause for 1/10 of a second or 100 milliseconds and get more continuous output, and at least still the rest of my computer isn't being denied service because this program is in such a tight loop. So that's a way to read the mouse location. The other thing we can do with the mouse, which is related to the exercise you're about to do, is find out whether the mouse is down or up. So let's figure that out too. So let's say boolean is pressed is equal to standard draw dot mouse pressed. And let's report on that as well here. Okay, so let's run this. Okay, so mouse pressed is false. Let's slow this down so it doesn't run away from us quite so much. Okay, so my mouse is not pressed. I'm going to click the mouse there, and now mouse pressed is true. And I'm going to release the mouse now, and so now it's false. So Sedgwick's API allows us to find both the location of the mouse and whether the mouse currently is down or up by standard draw.mouse pressed. What we're going to do here is play around with Sedgwick's keyboard demo, play around with the keyboard section of Sedgwick's API. And what we can do with that is we can tell whether a key has been typed and then find out what that key is. So let's just first figure out, did the user type a key? Now the way you might be tempted to do this is to ask whether has next key typed is true or false. And if it's true, you would say yes. And if not, you might say no. Okay, so let's run this program. And it always pops up the screen because we're using standard draw. And it says no, we don't really have much of a chance to type a key because this program runs so quickly that right away it says no, you haven't typed anything. So instead of checking whether the key has been typed just now, what we want to do is wait until the user has typed a key. So let's not do this. Instead, while there is no key typed, do nothing. So while it's not the case that we have a next typed key, we're going to do nothing. And then, once we get the key, we're going to go, got it. Okay. Now I could print out something in this loop, but it's just going to spin forever. In fact, if let's print not yet. And if we run this, we see that it's saying no, not yet. I'm going to type a J now, and it said got it, and the program ended. Let's see that again. So we're in our loop spinning, no, not yet, and the moment I type a key, suppose I type the K key, the program gets it and ends. Now this printing out in the middle really isn't so useful. I'm going to go back to just having a comment saying let's do nothing. And so now our program is waiting and waiting, and once I type a key, I'll type the L key. It says got it. Now you may recall from a previous video that we don't really want to spin in such a tight loop. But don't spin tightly. Pause. So I'm going to pause for 100 milliseconds. You're not going to notice the difference. The program's going to look like it behaves the same. But other programs running on the computer now get a chance to run as well. And I type the R and it says got it. Now what I'd like to do is find out what the key is. Instead of just saying got it, let's say what that key is. And to get that, we would say standard draw dot next key typed. So these methods work together. This is going to wait until a key has been typed, and next key typed retrieves what that key was. So we're waiting, and I'm not going to tell you the key that I'm typing, but it was a W in fact. Let's run it again. This time I'll type a different key, and it was indeed a 3. So this program waits until a given key has been pressed, doesn't matter which key, and then it reads what that key is. There's a standard problem that I see in students who use this interface, which is the following. Let's suppose that we want to get the key, and if it's one thing we want to do one thing, and if it's something else we want to do the other. So let's suppose that if standard draw dot next key typed is equal to a Y, then I'm going to print yes. And if it's equal to a no, an N rather, so else if standard draw dot next key typed is equal to a no, an N, I'm going to say that that means no, and I'll print out no. And otherwise, I'm going to say I didn't understand. So otherwise, do that. We're no longer going to print this out. Okay. The program looks like it's going to work properly, and let's take a look at it and see what goes wrong with it. So if I type a Y, it prints yes, and that's good. But what happens if I type a no, an N? So I'm running it this time. I type the N, and I get a problem. And we could go through the details of this problem, but we're not really in a position to understand it so well yet. Let me explain it in terms of the code. This code waits until a key has been typed. This gets the next key typed. And the next key typed, in this case, was an N. I compare it with a Y. This predicate is false, so I skip down to here. Then I get the next key typed, the one past the N that I just got. And there is no such key. I haven't typed anything yet. So this actually reads two keys in succession, and that's not what I had in mind. So to fix this, I'm going to retrieve the key that was typed by using this call here. And I'm going to replace this by got. If the thing I got is a Y, I'm going to say yes. If the thing I got was an N, I'll say no, and otherwise I'll say what. So I'm only reading one key. I'm not trying to read two in the case where I don't type a Y. So if we run this, I type a Y, we get yes. If I run it again, type an N, it says no, and that's proper. And if I type something else, I'm going to type a 2, it says what. So to avoid the mistake of reading past what the user has typed, you always have to see whether has next key typed is true, and then get the key, and capture the key if you want to make multiple comparisons.